aware of ourselves through our ability to experience and perceive the world around us. However, this raises a major question that scientists and great minds have yet to answer. That is, what is consciousness truly and where does its origin lie? According to Johannes Kleiner, a mathematician and theoretical physicist at the Munich Center for Mathematical Philosophy in Germany, consciousness, or more precisely conscious experience, is clearly a part of reality. We all experience it, but we still don't understand how it connects to the known physical laws. Our knowledge of the universe remains incomplete. Hoping that mathematics might unlock the answer, Kleiner and his colleague Sean Tull, a mathematician at the University of Oxford, UK, are exploring a philosophical approach called panpsychism. According to this view, consciousness is present even in the smallest units of matter, implying that the fundamental building blocks of reality may experience consciousness. If true, this means consciousness is not limited to humans or animals, but could be pervasive throughout the universe, latent in every element of the physical world. Is our brain capable of helping us visualize the entire universe? If scientists can decipher how the brain creates subjective experiences, then their mathematical model of consciousness could also extend to other inanimate forms of matter. Johannes Kleiner believes that a mathematical theory could apply to various systems, not limited to the human brain. If you develop a mathematical model of consciousness based on brain data, you can apply this model to other systems, such as computers or even thermostats, to see what it might reveal about their conscious experience. Some great thinkers have also supported this view of panpsychism, including many prominent physicists at Oxford like Roger Penrose. Penrose was among the first to propose that, to understand consciousness, we need to go beyond the boundaries of neuroscience and consider the role of quantum mechanics. He argues that human consciousness cannot be explained by mere algorithms, but may be the result of quantum effects. This idea was further developed by Penrose and anesthesiologist Stuart Hameroff in the form of a hypothesis called orchestrated objective. This hypothesis suggests that consciousness may arise from quantum oscillations in microtubules located deep within neurons, contrary to the popular theory that consciousness originates from connections between neurons. More importantly, the orchestrated objective reduction theory, there is a link between biological processes in the brain and the fundamental structure of the universe. Kleiner and Tull are now building on this idea to advance their research. They are also heavily influenced by the work of Giulio Tononi, a renowned neuroscientist at the University of Wisconsin, who developed the Integrated Information Theory (IIT). This is one of the most promising models of consciousness today. IIT posits that consciousness is a fundamental aspect of reality, existing with specific, unified, and definite properties. The core principle of this theory is that consciousness arises when there is information exchange between subsystems within an overall system. For an entity to be conscious, it must have unity and integration, and possess a property called phi, representing the degree of interdependence between subsystems. Simply put, imagine a pile of coins on a table, each coin symbolizing a group of neurons. These coins can operate individually as subsystems, but without information exchange between them, there is no phi, and thus no consciousness. The higher the degree of interdependence between subsystems, the greater the system's capacity for consciousness. Kleiner emphasizes that systems don't necessarily have to be biological to integrate information. He explains that integrated information is an abstract quantity that can be calculated as a sufficiently detailed description of the system. The result is a number denoted as phi. For example, with an apple, you could ask how much integrated information is in it. This is similar to asking how much energy the apple contains. You can also apply this concept to computers, just as we talk about entropy. Integrated information theory supports panpsychism to some extent, because according to this theory, even a proton could have a phi value. Like the apple, items such as thermostats or computers could possess phi, and this implies that even inanimate objects like your chair or table could contain integrated information, just like everything else in the universe. Empirically, there have been several independent studies that serve as verification components for integrated information. Integrated information theory includes a very complex when applied to a detailed mathematical description of a physical, it can determine whether that system is conscious and to what degree. An important point Kleiner notes is that according to the mathematics of integrated information theory, if a system is conscious, its individual components cannot have conscious experiences themselves. Only the entire system can experience consciousness, not its constituent parts. This also applies to the human brain, where certain regions in the cortex might be conscious. But the individual components making up the cortex, such as neurons, are not conscious. So what does this mean for the universe? Kleiner states that it is an isolated pair of particles floating in space and they interact appropriately. They can have a rudimentary form of consciousness. According to IIT, this means the universe is filled with forms of consciousness at various levels. However, does that have any impact on the physical nature of the universe? According to the mathematics of integrated information theory, a physical system will operate according to its laws, whether it experiences consciousness or not. Take the example of a computer. The mathematics of IIT might show that a computer could be conscious, but that doesn't change how it operates. This contrasts with the metaphysical foundation of IIT, which tends towards strong idealism. Kleiner points out that the mathematics of the theory might need future adjustments to reflect this more closely. Kleiner and Sundow's research is attempting to address such issues. Most existing theories of consciousness typically assume that physics governs everything. They reject the idea that consciousness could exist separately from or be superior to them, and instead assert that consciousness is merely a physical phenomenon, arising from interactions between physical quantities under specific conditions. However, the mathematical version of IIT developed by Kleiner and Sundow aspires to be a fundamental theory of consciousness. They're trying to anchor consciousness to the fundamental structure of reality, even if only in a very specific context. But if this theory shows that the entire universe is conscious, what consequences would that have? Would there be ethical implications? We often tend to treat systems with conscious experiences differently from non-conscious systems. If consciousness were proven to play a causal role in the universe, this would have profound impacts on the scientific worldview. It could trigger a scientific revolution, changing how we understand the relationship between consciousness and matter, as well as humanity's place in the universe.